Hello everyone and welcome back to Explore Engineering. Did you know that not every signal follows a fixed pattern? Some signals are completely unpredictable and these are called random sequences. Welcome to this MATLAB tutorial. In this video, we'll learn what a random sequence is, why it's important in digital signal processing, and how to generate it using a simple MATLAB program. We will visualize the random values using a graph and understand how every execution produces a different sequence. This experiment is perfect for the students preparing for DSP labs and interviews. So launch MATLAB, follow along with the code, and let's explore the exciting world of random sequences. So what is a random sequence? A random sequence is a discrete time signal whose values are generated randomly from a probability distribution. Unlike the other deterministic signals, the values cannot be predicted exactly. So this makes the random sequences useful for modeling uncertainty and noise in real-world systems. Mathematically, the random sequence is represented by x is equal to, here you can take it as x of n, that is the random values, and in MATLAB we can generate it by using these two commands, that is x is equal to rand of 1 comma n, which will produce a uniform random sequence, whereas x is equal to rand n of 1 comma n, it produces a normally distributed random sequence. So here this is a random sequence example. Okay, these are the random signals. Here you don't have any fixed value for the amplitude. So a random sequence, it does not follow any fixed pattern and each sample is drawn independently from a probability distribution such as uniform, Gaussian, that is a normal, and the Bernoulli, etc. These are the key aspects of the random sequence. First comes the characteristics, where the values are generated randomly. There is no fixed pattern or periodicity. Each sample is statistically independent. These can follow different probability distributions like uniform, Gaussians, and many more, then commonly represented using a stem plot in MATLAB. Next comes the applications. It is used in simulation of communication systems. It is used for noise generation and analysis, and also it is used in the filter design and testing, for performance evaluation of DSP algorithms, then Monte Carlo simulations, and wireless communication and signal processing. Now, what is the importance of this random sequence? It helps engineers test the performance of digital systems under noisy conditions, and they are widely used in digital signal processing, that is the DSP, in order to model the real world signals, evaluate the filters, and simulate communication channels. And understanding the random sequences is essential for designing reliable signal processing and communication systems. So this is the program where we are using the first instruction, that is the random, okay, that is rand of 1 comma length of n, which will produce what? Which will produce a uniform random sequence. We'll see for like the use of both the instructions here or the commands here. So this is the working of the program. Here we'll create a time index first. Like here this program, it creates a discrete time index from 0 to 40. That is, we are giving a total of 41 sample points. So 0 is also included here. 40 plus 1, 41. Then here by using the MATLAB's command or the function, that is a rand or rand, will generate 41 uniformly distributed random values between 0 and 1. Okay, that is the amplitude of this will range between 0 and 1. And these values form the random sequence. So here we'll create a discrete time index, that is, we'll use this function or instruction, that is n is equal to 0 is to 4, that is 0 colon 40. Now this statement, it will create the discrete time index n, and the sequence starts from 0 and it will end at 40. There will be total 41 sample points in. Okay, and these sample points numbers form the x-axis of the graph. Here you can see this is the x-axis, so 0 to 40. Next is the generation of the random sequence, where we are using x is equal to rand of 1 comma length of n, which will generate the random sequence, that is here we'll get the uniformly distributed random sequence or the random numbers, and here is this 1, it indicates that the output will have one row. Okay, here random of 1, it will have only one row. and the length of n, it returns the number of elements in n, that is which is 41. Okay, here 41 numbers. That is, we'll get here the value of x as 0.37, 0.91, 0.12, like this. Okay, here these are 41 values. Next is the plotting of the graph here. Okay, that is a random sequence. So for that we are using the stem of n comma x. So this stem function plots the random sequence as a discrete time signal. So we are getting the discrete signals here, and n represents the sample index. Okay, here n represents the sample index, that is the horizontal axis, and x represents the random amplitude values, that is the vertical axis here. Okay. Now each sample, it is displayed as a vertical line, that is the stem, and ending with the marker that represents the sample value. Here this is a dot node, this is a marker which ends the sample value. Now since the signal exists only at discrete values of n, the stem function, it is more appropriate than the plot function. Okay. So next comes the labeling of the x-axis and y-axis, and giving the title for the graph. So for that we are using x label of n, then y label of x of n, and title we are giving it as random sequence. Okay, then we are using the grid on here. So grid on, what it will do, it will display the horizontal and vertical grid lines on the graph, and the grid makes it easier to identify the sample numbers and the amplitude values. So this is the working of the program. Now we'll execute it. So I will copy the program from here. I'll paste it here. Okay, just a minute. I will write the 3 commands, that is the clc, then clear all, and close all. Okay, so now when I write these programs here, the command window will be cleared for clear all. Okay, so now I will run this program. See, this is for normally distributed random sequence. Okay, this one, because we are using here the command rand. Now I will change this to rand n. Now we'll see how we'll get the output. Run it. See, here we are getting like this. Okay, so this is the difference when we use the random command and then random n command. Okay, so this is about the generating of the random sequence by using the MATLAB. So now we have successfully learned how to generate and plot a random sequence in MATLAB, and we have explored the MATLAB program, observed the output, and understood that every execution creates a new set of random values. You can execute every time you will get different values. Okay. Now here random sequences play an important role in the simulations, communication systems, cryptography, then noisy analysis and testing algorithms. So keep experimenting by changing the sequence length and value range to better understand their behavior. So if this tutorial helped you, please like, share and subscribe for more easy to follow MATLAB and DSP lab videos. And thank you for watching, and see you in the next exciting experiment. Happy learning and happy coding.